Okay, Pawan, you start.
Yeah, okay. Uh, Hello. Arpita, what is the difference between the stress and pressure?
Stress is a tensor quantity where pressure is a scalar quantity. Pressure is restoring force per unit area, in which pressure is basically the magnitude of force per unit area. In the pressure, uh, in the pressure, we are in the pressure we only take the force applied is same everywhere. But in case of stress, there are two types. The force upon area, the force depending upon different directions. We are considering the directions also and the reference to the plane also.
Okay. Do you know about the density range for metamorphic rock?
No, I don't know.
Okay.
Sorry.
There is
Pawan, your voice is not audible.
audible.
Hello.
Pawan, you are not clearly audible. Please check your internet connection. Okay, Gauri, you please, would you like to ask some question?
Sorry, I will do it in a minute. I need some time.
Okay, Sanu?
Okay, I'll ask. So, what is difference between intensity scale and the magnitude scale?
In intensity scale, we are measuring how much loss has occurred during an earthquake, and its range is 1 to 10, whereas in the magnitude scale, we are defining the how much there is a ground shaking caused by an earthquake during on a particular location. It's and the magnitude is measured with the Richter scale, whereas intensity is measured by a Mercalli scale.
How many scale we have? Means at presently we are using how many type of scale?
We are using two types of scales. One is Mercalli scale, or we can say modified Mercalli scale, and the other is a Richter scale.
Okay. Uh, Can you tell about that the earthquake prediction about earthquake prediction? Means which method we are using for earthquake prediction and what are the evidence?
Basically, according to me, basically it's an idea. We are not able to predict the earthquake exactly, but we are able to tell about we have certain idea about the location only. Where, what is the probability or forecasting of an earthquake? That's all I know about this.
And that earthquake classification, do you know that difference between that intraplate and interplate earthquake?
Interplate earthquakes are those that are occurring within the plate boundaries, and intraplate earthquake are those which are occurring on the plates. Just give me a minute.
I think you just mentioned opposite one.
Interplate is the earthquake that are occurring between the boundaries between the two plates. And the intraplate is that is occurring within the interior of the tectonic plate.
Okay. Okay, and
Do I need
this
to tell any other classification also? Or you were asking about this only?
no, this only I was other classification you can
Oh.
okay if you know then you can tell
Other
as well.
classification, yeah, on the basis of the focal depth, there are three types of earthquakes: shallow earthquake, intermediate earthquake, and the deep focal earthquake. Shallow earthquake occurs when there is a focal depth of less than 70 kilometers. Intermediate earthquake occurs within the range of focal depth of 70 to 300 kilometers. And the deep focal earthquake, which occurs very rarely, with a focal depth of greater than 300 kilometers. And the other classification could be on the basis of magnitudes and the intensity. Yes.
Do you know about the isostasy? What is isostasy? Hello?
Basically, it is an equilibrium condition that pushes the lithosphere upward and the grav. Basically, it is an equilibrium condition that pushes the lithosphere upward and gravity forces that pushes the lithosphere downward.
Okay. Okay. There is how many hypotheses on isostasy? Do you know? Can you name
Three
them?
hypotheses are there: Airy-Pratt model.
Why they are called hypotheses?
I don't know about this.
Okay. Okay. This from okay. Anyone can ask question.
Yeah, yes. I'm audible, Anshudi?
Yes, yes.
Okay. So, Arpita, tell me what is the head wave
Just the head wave.
and in which condition we obtain the head wave?
When when we have a when you have an increasing velocity trend within the layers of the earth, we receive a head wave when there is a refraction from when a layer is going from one medium to another, and there is a refraction.
If the velocity decrease with the depth, then in this particular condition we obtain the head wave or not.
Can you please repeat your question, Pawan?
Yeah, yeah. I am say that if we go through the with the if we go through with the depth, in this case velocity is decreasing. So in this particular case, we obtain the head wave or not.
In that case, we are not going to receive the head wave.
Okay. And another question is the what is the difference between the potential and potential energy? What is the meaning of potential and potential energy?
Potential energy is a work done for bringing a point to for bringing a body from a point to an infinite position is known as potential energy. U is gm by r,
And
and
potential.
potential is
Okay. What is the principle of basic principle of format principle?
Fermat principle is the shortest travel time taken by a wave to reach from one point to another.
And Heisenberg principle?
Huygens principle, Heisenberg principle. Hello.
Heisen principle, yeah. Okay. Ansudev, I am done.
Uh, through which the new waves could be generated.
Okay, okay.
Okay, Amrit.
Okay, Arpita,
Yes.
uh, how will you classify the geophysical methods depending on the source or any external source used?
On the two ways we can classify it, on the basis of active methods and on the passive methods. Active methods in which an external source is used, whereas in the passive methods we are using the uh, we are using the natural sources. For the active methods, the example is seismic and the resistivity method, whereas for the passive methods, the example is gravity methods and magnetic methods also.
Okay, name some advantages of using active method and passive method.
In active methods, like we use a seismic method where we could get the information about the interior of the earth depending on our choice. And but on the passive methods, we could measure it through a particular process. We can say, like, if we are doing the gravity methods, so we are measuring the density contrast, or if we are doing the magnetic methods, we are measuring the susceptibility. We should have certain idea about that field also.
Okay, now you mentioned a few moments ago that there are two different scale, magnitude scale and intensity scale, right?
Yes, yes.
Consider one situation that you are having high Richter scale value but low Mercalli scale value. Can you suggest the possible scenarios?
If we have a low Richter scale value,
No, high Richter scale value and low Mercalli scale value.
Mercalli scale, it only describes the intensity. So if we have the low Mercalli scale value, then the observed effects would be less. Whereas the Richter scale, it describes the magnitude of an earthquake. But how could it be possible?
Okay.
Sorry, I don't know.
Okay, it's fine. Okay, now next, I am done.
Amrit, if you want, then you can answer this question.
Oh, I will answer later if let everybody ask.
Okay, Gauri.
Okay, Arpita, can you describe the processes that are being carried out from start to end in gravity survey?
Basically, the exploration of the gravity survey you are asking.
Yeah, there are process right now from measuring gravity to analysis.
Um, I'll try to explain this. Basically, our first stage is to do the prospecting survey of an area where which we can do through two of the methods, indirect or the direct methods. Indirect methods are those methods through which we are getting the information about the objects without touching the objects, which includes the remote sensing or any geophysical prospecting method. But in case of the direct methods, we can do it by touching, just like a well logging. Then there comes, we can use any of the methods. We are using the passive methods for the gravity. We are measuring the density contrast for that method. And then we are going to measure the particular gravity anomalies of that area by doing the detailed exploration for that area. And then we are going to place the gravimeter by, after placing the gravimeter, we are making the gravity profile according to that area, and then and from there we can get the density contrast of that particular ore body or whatever we are searching for.
Okay, um, if you are getting an anomaly of a particular place, what's the next process you are doing to that anomaly?
We are going to calculate the gravity value by doing that correct by putting that corrections into our gravity value. We are getting the observed gravity value.
Okay, okay. Um, can you name few techniques to separate the regional and the residual anomalies? First of all, can you differentiate regional and residual anomalies in gravity survey?
Yes. Regional, uh, just a minute. Basically, the regional anomalies that are done for the great depths, whereas residual anomalies are done for small depths. Regional anomalies uses the long, it is of long wavelength, whereas the residual anomalies are for the short wavelengths. And residual anomalies covers the large distance, but the regional anomalies covers the small distance. And regional anomalies, they vary slowly with the distance, but the residual anomalies varies greatly with the distance.
Okay, so the methods used to separate them, can you name any two?
By use of, I'm not sure, but by use of filters,
Yeah. Any other method?
upward and
Can
downward continuation techniques.
can we separate it with visual analysis or
Sorry, I don't know about this.
okay, okay. Um, can you give an idea about the sign conventions used in free air, boger, and terrain corrections?
In free air correction and Gauger corrections are always opposite. If you're talking about free air correction, if you're standing on a datum, there might be two cases. If you're taking the measurements above the datum, or if you're taking the measurements below the datum. If you're taking the measurements above the datum at a certain height h, then the free air correction will be positive. But if you are taking but if you're taking the reading below the datum at certain depth h, then the free air correction will be negative. Borger correction is applied when there is a mass between the datum and at a height h. So, due to that mass, Borger anomaly comes into Borger correction comes into action. So, if we are taking that correction, so Borger correction will be negative if we are taking it above the datum, but it is positive when we are taking it below the datum. So, in this way, these both corrections are opposite in nature, and the terrain correction is always positive.
Why is it so? Hello?
Yeah,
Can you
terrain
answer?
correction. Yeah, I will try to do this. Terrain correction happens when there is a undulated topography. On the one hand, there is a mountain, and whereas on the other hand, there is a basin. So, mountain will try to exert the due to the excess of mass in the mountains, it will try to exert more gravity. But on the other hand, where there is a basin, it will not there is a deficiency of mass. So in that way, uh, the po- in that way, the effect of the gravity due to the mountain will be more, I could say that. And in this way, the terrain corrections are always positive.
Okay, okay. That's all.
Agya,
Okay, Orpita. Am I audible?
Yes, yes.
Okay. So, what is the difference between a seismograph and a seismogram?
Seismograph is an instrument that records the intensity of an earthquake, where the seismogram is a recorded graphical output of the instrument.
Okay. So, what type of seismometers are there according to the motion of the Earth?
Two types of seismometers are there: vertical motion seismometer and the horizontal motion seismometer.
Can you name the waves detected by both of them? I mean, vertical seismometer can detect which waves, and horizontal seismometer can detect which type of waves.
Mm,
In terms of P wave, S wave, which
okay.
cannot be detected by horizontal seismometer, I want to
P
ask
waves
this.
are detected through the vertical motion seismometer, where the S waves are detected through the horizontal motion seismometer.
Okay. And okay, what are the similarities between gravity method and magnetic method?
Similarities.
Okay, can you explain upward continuation and downward continuation?
No, I don't know about this.
Okay. Okay, I'm done.
okay. So, Arpita, what is geodesy?
Hello.
Hello, am I audible?
Yes, yes. Can you please repeat your question?
What is geodesy?
It's a branch that is dealing with the shape and area of the Earth.
So can you tell me about the figure of the Earth or say?
It's a oblate spheroid or geoid.
So any difference between geoid and the oblate ellipsoid?
Of geoid and ellipsoid, you are asking, right?
Yes.
Ellipsoid is a mathematical it's a mathematical assumption for our calculations. We are taking That's why we are taking the ellipsoid for our mathematical calculations, whereas geoid is the actual shape of the Earth.
Okay. So geoid is the actual shape of the Earth, but why we are not using it if it is actual?
Because there are so many undulations in the geoid, मतलब बहुत सारी जगह पे हमारे पास माउंटेन्स हैं, बहुत सारी जगह पे रिवर्स हैं, तो हम उसे एक पर्टिकुलर उसमें कैलकुलेट नहीं कर सकते हैं. दैट्स व्हाई वी आर टेकिंग अ रेफरेंस ellipsoid.
Okay, so how will you define the geoid undulation?
Basically, geoid undulations are those where there's an increasing density with the depth, but not for the lateral variations.
Okay, suppose we have the mass axis below the ellipsoid. So what will be the sign of the geoid undulation? Will it be positive or negative or zero?
If we have a mass axis below the ellipsoid,
Yes, below the reference ellipsoid surface.
it will be positive
Okay, why?
because the just a minute. Because of the attracting material above the ellipsoid geoid. Basically, it is a h minus h height relative to the ellipsoid, height relative to the ellipsoid minus the elevation relative to the geoid.
Okay, okay. Let me help you with this. Have you heard about geopotential?
Yes,
So how will you define it?
surface having a constant potential are known as geopotential.
Okay, so it includes which kind of potential?
It includes the when we have a spherical shape of the Earth, then it is
Okay, okay. Comes to the gravity measurement. So how we can measure the gravity? Okay, so before this, why do we need to correct the gravity value?
because we are measuring our gravity value at the datum, but due to the height, as gravity depends upon various factors, gm by r square. So to take that factors into the account, we are using the corrections.
Okay,
Whether it is
so
due to depth or due to height or the
okay,
mass system.
so is there any difference between the gravity correction and gravity anomaly in terms of their cause?
Sorry, I don't know about this.
Okay, so can you tell me the cause of the gravity correction? As you have told, it depends on the latitude, elevation. No. So why? So what is the reason behind the gravity anomaly? The main reason.
Mm, First is the shape of the Earth, then the mass distribution inside the Earth, and the density variations.
Okay, okay. So, okay, in the during the gravity survey, we use the absolute value gravimeter and the relative value gravimeter. Can we use absolute value gravimeter in the field?
We cannot use the absolute gravimeters in the field because they will directly measure the acceleration. They will directly measure the acceleration of the mass that is freely falling.
Okay, there is
Relative
no problem.
measurements. Sorry, what are you saying?
Okay, there is no problem. Once we have the absolute value, we will just subtract with the reference value. There is no problem. Still, we are not using absolute value gravimeters. Why?
Because they are more compact.
Okay, okay. So, what is the modulus constant?
It is stress is directly proportional to strain. So to remove that proportionality, we are using the modulus constants.
Okay, and what is stress and stress?
Stress is force upon force per unit area is the stress. Strain is the change in the length, ratio of the change in the length to that of the original length.
So, is there is a difference between the stress and the pressure in terms of force?
Yes, force is the pressure is the magnitude of the force dividing per unit area, whereas the stress is the restoring force per unit area.
Okay, thank you. Okay, for the feedback, you can give one by one. Pawan, with अगर आपको जो आंसर लग रहा है अच्छे से नहीं दिया था, then you can also tell. Okay.
ओके। अर्पिता, मेरा पहला क्वेश्चन था व्हाट इज द हेड वेव। तो और कब इसका मतलब कब होती है हेड वेव, कब इनका जनरेशन कब होता है। तो आपने सही बताया कि जब वेलोसिटी इंक्रीज करती है डेप्थ के साथ में तो हेड वेव जनरेट होती है। हेड वेव इलास्टिक वेव भी होती है। और उसके बाद मेरा सेकंड क्वेश्चन था, क्या था मैं भूल गया सेकंड क्वेश्चन। हाँ, डिफरेंस बिटवीन द पोटेंशियल एनर्जी के बारे में आपने ठीक बताया था, बट प्रिसाइज आंसर नहीं था उसमें, है ना। और एक वो था, एक क्वेश्चन वो मेटामॉर्फिक रॉक के लिए डेंसिटी का वेरिएशन 2.5 से 3 के रेंज में होता है ना।
Okay.
और आप स्ट्रेस एंड प्रेशर में डिफरेंस था, तो हाँ वो ठीक था। बस कुछ रिवीजन की जरूरत है, पर ठीक है आई थिंक।
Thank you.
Gauri,
Yeah, my first question was the processes that's involved from measuring to analysis of gravity survey. And what I meant is mm, the analysis of the field and then applying error and its residual and regional anomaly separations, um, interpretation. That's what I meant. Um, and other question.
You asked about the variation methods for the anomalies, regional and residual.
Yeah. It involve it. We can measure it. We can analyze it by visual analysis and we can apply polynomial representations for the regional anomalies and fit it appropriately using least square method, and then eliminate the regional anomaly from the remaining. And there are Fourier representation and further filtering, um, and doing convolution, and uh, so the such four methods that's mentioned in Lori. There are many furthermore, I think. Um, and next question was about the terrain correction.
Yes,
Uh,
correction.
yeah, it's the correction that we are applying due to the variation in the topography, and you said it partially. Uh, and in the case of mountain, where there is a upward attraction due to the mass, it will lowers the it will reduces the value of gravity we measure. So we try to compensate that and add that value. Whereas in the case of valley, there will be a deficiency of mass, which will also cause a reduction in the measured gravity above it. So we will again add that for the lack of mass in that area. That's all where the question, I think.
जो आपने वो पूछा था कि ग्रेविटी सर्वे के स्टेप्स that was right.
You were telling about the interpretation, right? Direct and indirect methods.
हाँ, उसके बाद मैंने
What I
exam
meant,
बताया था.
I meant you are, first of all, we are measuring the field, and
Okay.
then we are applying the corrections. After that, we will calculate the anomaly. Further, we separate region and residual anomaly, and next is interpretation. That's what I meant.
Okay.
सानू,
हाँ, एक्चुअली मैंने जो पूछा था मतलब सभी मतलब आंसर ठीक ठाक था, बट एक क्वेश्चन मैंने आज मतलब व्हाई दे आर कॉल्ड हाइपोथेसिस, तो उसके लिए हाँ, तो देयर में डिफरेंस होता है मतलब लॉ, थ्योरी एंड हाइपोथेसिस। तो जो लॉ होता है वो साइंटिफिकली एस्टेब्लिश होता है, एक्सपेरिमेंटली प्रूव होता है, प्रूवन होता है, और जो हाइपोथेसिस हाइपोथेसिस है वो उसके मतलब इनडायरेक्ट एविडेंस मिलते हैं, मतलब डायरेक्टली वी कांट प्रूव इट, डायरेक्टली हमें मतलब फैक्ट्स के साथ हम नहीं जा सकते। अब थ्योरी तो हम मींस वी आर एज्यूमिंग इट, हमें अभी तक कुछ एविडेंस नहीं मिला, जस्ट वी आर फिटिंग इट, इन फ्यूचर मे बी इट्स एस्टेब्लिश्ड। ओके,
इन दी सिंपल लैंग्वेज की जैसे कि बहुत प्लैंक्स हाइपोथेसिस थी कि अगर आपको प्रूव करना है तो ये मान लो, नहीं मान रहे तो नहीं प्रूव कर पाओगे, राइट सानू?
हाँ, सिमिलर काइंड ऑफ।
ओके ओके, अमृत?
हाँ, तो मेरा तो एक क्वेश्चन था ग्रेविटी से कि वो एक्टिव पैसिव के बारे में, तो तुम सही बोली। और नेक्स्ट क्वेश्चन वाज ऑन द डिफरेंस ऑफ रिक्टर स्केल एंड मार्कली स्केल, तो ये भी यू आंसर्ड, तुम सही बोली, क्योंकि तुमको थोड़ा ये भी डिफेंड भी करना चाहिए, उसमें थोड़ा कॉन्फिडेंस भी दिखाना चाहिए था ही बस। कोई भी रीजन में रिक्टर स्केल में मैग्नीट्यूड ज्यादा है मतलब ऐसा नहीं कि वो डैमेज ज्यादा करेगा, क्योंकि अगर वो लेस पॉपुलेटेड है, पॉपुलेशन नहीं है, तो डैमेज नहीं करेगा। इंटेंसिटी स्केल व्हाट डज इट मेजर? इट एक्चुअली मेजर्स द डैमेजेस। सो अगर कोई पॉपुलेशन नहीं है, कोई एकदम बैरन ग्राउंड है, तो उधर तो मार्कर स्केल में ऑब्वियसली लेसर वैल्यू आएगा। तो यही था, तुम सही बोली थी, बस थोड़ा कॉन्फिडेंस दिखाना चाहिए था। और सजेशन, कोई भी आंसर तुम जब दे रही हो तो मुझे लग रहा है थोड़ा टाइम ज्यादा ले रही हो, प्रोबेबली हो सकता है कि रिवीजन सही से अभी चल रहा है तो सही हो जाएगा। और जब नहीं आ रहा है तो लास्ट लास्ट तुम ऐसा बोल रही थी कि सॉरी मुझे नहीं आ रही है, ये सही है। लेकिन पहले इनिशिएशन में थोड़ा बहुत मतलब मुझे ऐसा लग रहा था टाइम लग रही है तुमको, तो ये थोड़ा देख देख लो।
Okay, I'll try to improve it.
ओके, आ
हाँ।
गया।
वो अमृत, वो वाला एडवांटेज एंड डिसएडवांटेज ऑफ एक्टिव एंड पैसिव वो थोड़ा बता दो।
अच्छा, हाँ, पैसिव मेथड्स आर नॉर्मली those where we don't use any external sources, so we use the natural sources. In these cases we have deeper information, we have deeper depth of penetration information, and we don't have the resolution as good as active one, but we have deeper information. And in case of active method, normally we use external sources, but it can't penetrate into deeper depth, so we have less depth information but the resolution is good. This is the main difference.
ओके।
सो एक्टिव मेथड में अमृत रेजोल्यूशन अच्छा होगा बट सैलो डेप्थ इंफॉर्मेशन होगी, हाँ।
हाँ, comparatively depth of penetration कम रहता है।
ओके, द क्वेश्चंस आई आस्क्ड and the phases which can be detected by vertical and horizontal seismometer. In vertical seismometer can detect P wave, SV wave, and Rayleigh wave, and horizontal seismometer can detect P wave, SH wave, Rayleigh wave, and love wave. And the similarities between the gravity and magnetic method is that both are passive method and both are potential method. And upward continuation is simply we measure the field at some point and we continue the field upward, like without measuring we just extrapolate the field to some value at a point above the measured location. It reduces the short wavelength data. And for downward continuation is we measure the field at some point and we continue it downward, and it actually reduces the high wavelength component. That's all.
Okay.
सजेशन फॉर अर्पिता आ
I
गया।
yes, I think she needs to be more confident, and that's it.
Okay, thank you.
ओके, सो द फर्स्ट क्वेश्चन आई हैव आस्क्ड अबाउट द जियोडेसी। सो जियोडेसी इसलिए है कि वो जितने भी रेफरेंस एलिप्सॉइड है, पोलर फ्लैटनिंग, ये सब कॉन्सेप्ट इसमें ही आएंगे सारे। जियोइड, जियो पोटेंशियल। सो नॉलेज आंसरिंग तो अच्छी है, बट जहाँ आपको नहीं पता तो यू आर सेइंग ओके आई डोंट नो, गुड। बट जहाँ आपको पता होता है ना तो एकदम से यू यू आर शोइंग की अच्छा ये तो पता है अभी बताते हैं। जस्ट टेक सम टू टाइम्स 5 or 1 or 2 सेकेंड, देन ट्राई टू एक्सप्लेन कि लगे हाँ कि हाँ अंदर से आ रहा है, ये नहीं कि जो अच्छा ये याद था तो आपने एकदम बता दिया, जो ये नहीं था वो आपने एकदम मना कर दिया। टाइम लो, जो आता है उसे भी बताने में थोड़ा मतलब 1-2 सेकेंड का पॉज लो, ठीक है। एंड वन क्वेश्चन, द जियो पोटेंशियल क्या होते हैं? इट इज इंक्लूड्स द ग्रेविटेशनल पोटेंशियल प्लस द सेंट्रीफ्यूगल पोटेंशियल। सो वो आप पढ़ लेना। एंड सेकंड था कि एब्सोल्यूट ग्रेविटी मीटर हम यूज कर सकते हैं नहीं, हाँ वी कैन यूज, बट उनकी प्रॉब्लम क्या है? वे फर्स्ट ऑफ ऑल बल्कि हैं, एक्सपेंसिव होते हैं, एंड देन स्लो रीडिंग है उनकी। सो 30-30 मिनट्स तक वन रीडिंग के लिए हमें वेट करना पड़ सकता है। सो इतना तो टाइम नहीं है हमारे पास। सो दैट्स वाई हम फील्ड सर्वे के लिए रिलेटिव मेजरमेंट ग्रेविमीटर यूज करते हैं। एंड लेट्स ऑल। सो अच्छा है काफी कम्युनिकेशन वगैरह आपका। बस यही पॉइंट है कि आप थोड़ा मतलब वही है कि जो आता है उसे भी थोड़ा सा टाइम लेके देंगे ना कि ये एकदम से बोल दिया है।
Thank you.
Oh, and what about the why geoid undulation is positive when there is excess mass, and what is the reason?
ओके ओके, सो जॉइड इट इज इट सो ग्रेविटी जो जॉइड है, इट इज द इक्विपोटेंशियल सरफेस सो जो पोटेंशियल है वो ग्रेविटेशनल और उसका सेंट्रीफ्यूगल पोटेंशियल का कॉम्बो है। सो जब मास एक्सिस, ये दो केस होते हैं इसमें, जब मास एक्सिस होगा below the ellipsoid and above the ellipsoid भी होगा, उन दोनों केसेस में वो पॉजिटिव जियोइड अंडुलेशन आती है। इट इज बिकॉज ऑफ पोटेंशियल इंक्रीज हो जाता है। सो जो हमारा जियोइड है वो एलिवेट्स होके ऊपर की तरफ चला जाएगा। एक्चुअली ज्यादा अंडरस्टैंडिंग के लिए तो बहुत कॉम्प्लिकेट प्रोसेस है, बट हाँ जनरली हम यही जो भी डेफिनेशंस वगैरह दी हुई है लोरी में यही है वो।
Okay.
और ये प्रेशर और स्ट्रेस वाला कॉन्सेप्ट, इसको भी थोड़ा
ओके
बता
ओके
दो।
ओके ओके। सो स्ट्रेस इज द टेंसर क्वांटिटी, बट प्रेशर इज द स्केलर, ये तो सबको पता है। बट टेंसर क्वांटिटीज में क्या है कि हमें इन्हें डिफाइन करने के लिए तीन चीजें चाहिए। फर्स्ट, वी रिक्वायर द मैग्नीट्यूड, सेकंड द डायरेक्शन, थर्ड इज द एक्शन ऑफ प्लेन। किस किस हमें प्लेन पे से अप्लाई कर, डायरेक्शन ऑफ द प्लेन, सॉरी एक्शन नहीं, डायरेक्शन ऑफ द प्लेन, किस प्लेन पे अप्लाई करनी है हमें। सो दैट्स व्हाई ये डिफरेंट होते हैं। स्ट्रेस इज टोटली इंटरनल क्वांटिटी विच अराइजिंग ड्यू टू द इंटरनल फोर्स, द रिस्टोरिंग फोर्स इसका एग्जांपल है। बट प्रेशर कैन बी इंटरनल और एक्सटर्नल। ये जो मेन डिफरेंस है इसका यही है कि इंटरनल जो रिस्टोरिंग फोर्स है वो स्ट्रेस डेवलप करता है, और वो परपेंडिकुलर
I
फोर्स,
think
अगर आप फॉर्मूला आप देखोगे ना तो वो आएगा कि रिस्टोरिंग परपेंडिकुलर फोर्स अपॉन एरिया, और प्रेशर की डेफिनेशन डिफरेंट होती है वो। आ गया आप
there
कुछ
can
बोल
be
रहे।
there can be stress from outside also. I think if I apply pressure from outside, it can also produce stress, I think.
हाँ, अगर आप ओवरऑल सिनेरियो में देखोगे ना, इट कैन बी, बट जो स्ट्रेस होती है वो इंटरनली ही रिस्टोरिंग कॉन्सेप्ट है। बिकॉज आप प्रेशर बाहर से अप्लाई करोगे सपोज किसी मटेरियल पे, देन उसके कोरस्पॉन्डिंग एक न्यूटन थर्ड लॉ के अकॉर्डिंग एक रिवर्स फोर्स अप्लाइड होगा। वो सपोज आपने किसी मटेरियल को एक्सटेंड करना स्टार्ट किया, तो आपने फोर्स तो बाहर से ही लगाया, बट उसके अगेंस्ट में जब वो मटेरियल एक्सटेंड होना स्टार्ट करेगा, देन उसमें एक इंटरनली एक रिस्टोरिंग फोर्स डेवलप होना स्टार्ट करेगा विच विल ट्राई टू रिफॉर्म दी और रिबाउंड दी मटेरियल इन दी अपोजिट डायरेक्शन। सो स्टेसिस उस वजह से जो उसके क्रॉस सेक्शनल एरिया में फोर्स लग रहा है उसकी वजह से है रिस्टोरिंग।
Okay.
ओके।
नेक्स्ट गौरी, वुड यू लाइक टू?
Okay. I want to give because I would not be available after 10, I think. So,
ओके ओके ओके, आ गया। ओके पवन, ओके यू कैन स्टार्ट।
Yeah, yeah. Arke, what is the elasticity?
elasticity is the property of the material by which, when it is deformed, it wants to return to its original shape.
I give two material. One is the steel, and another one is the rubber. So in which we have more elastic.
Steel will be more elastic.
Why?
Okay. I don't know why, but it will have, I mean, the tendency to come back to its original shape is more for steel, I think.
Okay, okay. What is the difference between topography and tomography?
Topography is the undulation of Earth's surface, and tomography is a process. Actually, by seismic tomography, we calculate the velocity distribution of subsurface of Earth. Tomography actually means by subdividing it into cross sections. So, what we actually do in tomography, we assume a velocity distribution by we divide the Earth surface by cross section, and we assume a velocity distribution. Then, from travel time, we calculate the travel time residual and calculate the velocity anomaly. By this, we can get the actual velocity distribution in the Earth. So this is tomography, and topography is what I said.
Okay. Do you know about the relation between the Poisson ratio and velocity of P and S wave? And what is the
Yeah,
importance?
yeah. Ratio of VP, if VO velocity is VP and SO is VS, then ratio of those two, VP by VS, is equal to root over 2 minus 2 sigma by 1 minus 2 sigma.
What is the importance of this formula?
And importance is by measuring the p wave and s wave velocity, if we have that information, we can get we can easily calculate the Poisson's ratio. And the Poisson's ratio is a indicative of the rock lithology. Actually we can measure porosity from Poisson ratio, and also we can tell about the lithology of the rock. So this is the importance of the relation.
Do you know which rock have higher Poisson value, Poisson ratio value?
Yeah, I knew, but I forgot. I am sorry.
Okay. Do you know for sandstone rocks have a density range? Which type of density range sandstone rocks?
Sandstone.
Yeah.
Sandstone. Actually, most of the rocks have 2.3 gram per cc. I think sandstone will be between 2.1 and something. I don't know exactly.
Okay, okay. Actually, I have done.
Arpita?
I will take a minute.
Okay, Gauri?
Okay, okay. Um, which seismic wave will be more destructive? I think.
Uh, I have actually surface wave will be more destructive, though it will comes later, but it has more amplitude than the body wave, so it will be more destructive. And Rayleigh wave has a retrograde ellipse type of motion that can cause destruction. And again, lava wave has I think more amplitude and more velocity than Rayleigh wave, so it can be also destructive. So both the Rayleigh and lava waves will be destructive, I think.
Okay, okay. Mm, can you suggest some ways to minimize the earthquake damages?
Sorry, repeat please.
Can you suggest some ways that so that we can reduce the earthquake damage in an area?
Oh, I think you
Or
before
some
the
measures?
earthquake or after the earthquake?
Bef-
Before.
both. Mm, before.
Uh, I think I don't know about the measures. I know about the prediction. I don't know what measures. Sorry.
Okay. Then have you heard of seismic microsonation?
Seismic micro,
Sonation.
seismic microzonation. Yeah, I think I can tell briefly about it. That to reduce seismic hazard, actually we divide a zone into small zones. We divide a big area into some small areas, like a city into some districts, or so that we can assess the hazards and risk associated with each of the short areas to uh, act more potently. That is, I think, in brief, that is microzonation.
Okay. Mm, that's all.
Okay, Sanu?
Okay. Do you know what the T diagram?
Please repeat.
What is the diagram for the earthquake?
Quadratic diagram is the we plot the difference between travel time of S wave and P wave, Ts minus Tp in y-axis, and the TP along travel time of P wave along x-axis, and the slope of the curve is alpha by beta minus 1. Actually, alpha is the velocity, Vp by Vs minus 1. So from the slope we can have an idea about the ratio of Vp by Vs, and from the intercept we can get the origin time of the earthquake.
Okay, from quantity diagram we can know that focal depth.
Focal depth? No, I don't think so. We cannot estimate the focal depth. We can estimate the epicentral distance, but focal depth, no.
Okay. Okay.
Actually, we can. I think we can estimate the focal depth because if we know the distance traveled, and we can measure the epicentral distance also, so we can know the focal depth from those two data. So yes, yeah.
Yes. Okay. You know the type of fault mechanism.
Okay, there are three types of fault, mainly two types of fault: deep slip and strike slip. So deep slip faults are of two types: normal fault and reverse fault. So in case in normal fault, in case we imagine two plates, we call one foot wall and we call another one hanging wall. So in normal fault, the foot wall moves upward, and the hanging wall moves downward. So it is actually associated with the uh, conservative plate margin, and in reverse fault the opposite case happens, and it is associated with the destructive plate margin. And another one is strike slip fault. In this case, the two walls, the two plates move horizontally. uh, so if the upper plate moves right, it is dextral, and if the upper plate moves left, it is sinistral. And the another one is transform fault. It is a variant of the strike slip fault.
Okay. So you know that how the earthquake energy is calculated.
uh, Earthquake energy, actually there is a formula of logarithm of energy equal to, I think, 1.5 into magnitude into something. There is a formula. We can calculate energy from magnitude. Actually, energy is the square of amplitude. From that concept, we can calculate by energy by formula.
Okay. Means we have the two scale now. One is the means actually we have the means body wave and intensity के three scale we have now.
Yes, yes.
So which one use in energy calculation?
Which scale? I
Means
think
body wave
we.
magnitude or surface wave magnitude or moment magnitude.
Okay. I think surface wave magnitude. I'm not sure.
Yes, surface wave magnitude. Okay, that's from me.
Arpita?
Amrit, yeah, what is earthquake?
Okay. Earthquake is the shaking of the ground caused by some plate tectonics, and it is a phenomena that can be of very small magnitude and very large magnitude. Actually, it is the shaking of the ground
Okay.
due to some
So,
mechanism.
okay. What is the difference between seismology and the seismic?
In seismology is associated with the earthquake. I mean, it is a natural source, and we cannot control this source. And in seismic, it is actually we use some source, that is we can control the source like vibrator, yeah, explosive. And in seismology we get the information from very deep of earth. We can get the information of the internal structure of earth. But in seismic method we obtain the information from a shallow depth, about tens of kilometers only. And in seismology the frequency of the source is limited. I think it's low frequency, but in seismic method we can control the frequency also. It can be, can use low or high frequency. These are the differences.
Okay. What is the difference between reflection and the reflection seismology?
First of all, the technique is different. In reflection, we use the phenomenon of reflection. Reflection, that is the ray hits an interface and it comes back to the surface. And in refraction, the ray hits the interface in a critical angle and then traverses through the deeper layer as head wave and then comes back to surface. So in refraction, we can get to greater depth, uh, as we can involve two or more surfaces. But in reflection, uh, we can get the information of the upper layer only. Though by incorporating some other method, we can use multi-layer reflection also. But actually, reflection gives the better depth. And in reflection, we get a better subsurface image than reflection. So reflection can be used for hydrocarbon exploration. And this is the main differences, I think, and there are also many other.
Where do we use the reflection seismology?
We use refraction seismology in case of groundwater exploration, because there is a velocity difference for the rock and the water layer, between rock and water layer. We can also use it in construction sites to estimate the depth to the rock. And these are the main uses, I think.
Okay, thank you.
Amrit,
Okay, Orgo.
Yeah.
Uh, why will we use gravity method?
Why? Actually, there are density variations in the subsurface. We know the value of gravity from theoretical formula at every point of Earth, but due to density variation in the subsurface, the value deviates. So by measuring the gravity value at any point and by correcting the gravity value, we can tell what is the cause of this anomaly, what is the, and we can, from that we can tell if there is any anomalous substance present in the subsurface. That is why we use gravity method.
What type of density anomaly we measure in gravity method?
What type of? I don't understand.
Is it horizontal gravity anomaly or vertical anomaly?
Vertical anomaly, actually.
Okay, just consider at a depth of D1, or you are measuring the value at a particular location. Two bodies are there at different depth. Will you be able to differentiate between these two? At just consider 1 kilometer, another is at 2 kilometer.
Okay. The If the shape is same, then the pattern of the anomaly curve will be same, but the amplitude may be different, because gravity value is proportional to 1 by square of the distance. So I think the amplitude will be different between in the two cases.
Okay. Now, in your previous answer, you mentioned about faults.
Yeah.
What is fault?
Fault. What is fault? I don't know the definition actually. Sorry.
Okay. Why should we study seismology?
We should study seismology because it uh, it gives us an idea about earthquake, why it occurs, and how can we prevent the damage, and etc. And also it gives us an idea about the internal structures of earth. These are the main reasons, I think.
Okay. Why Richter scale is called local magnitude scale?
I don't know.
Okay, it's fine. I'm done. Ashudeep, you can ask now.
Okay. Okay, with respect to the gravity method, how many type of gravity corrections do you know?
There are many corrections. First of all, latitude correction, then tidal correction, then drift correction, then terrain correction, then Boger plate correction, then Freer correction. Uh, that's it.
Okay. What is the train chart?
Terrain chart. Actually, I skipped the part. Actually, I can't
Okay,
explain.
okay. So, can you tell me the sign of the train correction? Okay, what is the reason of the train correction?
Reason is the undulation of topography. Suppose we are our measuring point. There is a besides our measuring point, there is a mountain. So this mountain will cause an upward gravitational attraction. So our measured gravity value will decrease. So we have to add the correction. And again, suppose there is a valley besides the measuring point. So there is a lack of mass. This would also decrease the measured gravity. So we should add the terrain correction. This is the reason of doing terrain correction.
So, will we always add the train correction? Or can we avoid it? What is the condition for this? Is there any condition?
Condition to avoid it.
Yes.
I think terrain
Or
correction is very
condition
small.
or conditions to avoid it or include it? When should we include the terrain correction?
I think terrain correction should always be included if there is the topography variation like mountain or valley, but it is very small in magnitude in respect of the actual gravity value, and the process is also very difficult and time taking. So we usually avoid it.
So, what is the order of this correction?
I forgot the order. Sorry.
Okay. So, have you heard about the Avatos correction?
Hey, yeah, if we this is correction is done when the measurement is taken from a moving vehicle. Actually, the component of the centrifugal acceleration. Suppose there are for a moving vehicle there are two components. One is eastward component and one is northward component. For a eastward component, we can also divide it into two components. And for the vertical component is decreases the measured gravity. So, so for a eastward moving vehicle, we actually add the Eutovos correction because the measured gravity value is decreased, and for westward moving vehicle we subtract it.
Okay, so is there a difference between the Coriolis acceleration and the Avatos acceleration?
Yes, those are as I said, there are two components, one horizontal and one vertical of the eastward velocity. So the horizontal component actually is responsible for the Coriolis force. It is like If some body is moving on Earth, the Coriolis force will act to its right if in northern hemisphere, and in southern hemisphere it is opposite. So the Coriolis force actually, mm, yeah, these two are different.
Okay. Can we model the gravity anomaly? Are there any models?
Yeah, we can model gravity anomaly like a sphere for a salt dome, and like uh, for a horizontal cylinder for a uh, horizontal cylinder and a horizontal line. They are like this. We can model the gravity
Okay, okay.
anomaly.
Suppose you have a spherical object, buried spherical object, and the cylinder at the same depth. So from the anomaly curve, how will you differentiate? It is from the cylindrical buried object or due to the spherical object.
So I think the for the cylindrical object, the anomaly curve will fall slowly, and the for sphere it will fall rapidly because due to the more horizontal extent of the cylinder.
Okay. And what is the logarithmic potential?
What is the
Logarithmic potential.
logarithmic? I don't know. Sorry.
Okay. Uh, what is the equipotential surface? What are the
Equipotential. Sorry.
characteristics of the equipotential surface?
Equipotential surface is the surface of same potential energy. And in case of Earth, it is spherical if we consider Earth to be a sphere, as the potential energy varies with 1 by r. R is the radius. So if r is constant, the potential will be constant. So equipotential surface will be a sphere, ideally, and and there will be no work done if we move along equipotential surface, as potential energy is same. And we also define vertical and horizontal in terms of equipotential surface, because the normal to equipotential surface will be vertical, and these are the characteristics.
Okay. And what is seismic waves?
Seismic waves is a packet of energy, actually, that is caused from the seismic source, that travels away from the seismic source, and that travels due to the elastic properties of Earth by either compressional movement or shear movement. And yes, this is seismic wave.
Can you classify them?
There are two types of seismic wave: body wave and surface wave. Body wave propagates through the body of Earth, through internal layers of Earth, and surface wave propagates to the surface of Earth. Body waves are of two types: P wave and S wave, and surface waves are two types: Rayleigh wave and Law wave.
Okay. So which wave will reach the at the seismograph first?
P wave,
Why?
because it has higher velocity. The velocity formula is, I think, root over k plus 4/3 of mu by rho, where k is bulk modulus and mu is shear modulus and rho is density. So it has more
Okay.
velocity.
Can you explain this in terms of the other reason or the in terms of the wavefront?
Wavefront. I think I think for P wave, I don't know in terms of wavefront, but as P wave is compressional wave, the particle motion is along the direction of wave propagation. So this can be a reason. I
Okay.
cannot explain in terms of
So
wavefront.
now can you explain the body waves and surface waves in terms of wavefront, their propagation velocity?
In terms of no, I can't. I am not.
Okay. 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 Let's come to the PE and S waves. So, okay. So, what is the formula for the velocity of P wave and S wave?
I just told for P wave, and for S wave, there will be the shear modulus will be zero. So root
Okay.
over
So,
mu by rho
from
actually.
these two formulas, now can you tell about the mechanism behind the propagation of P wave and S wave?
Mechanism is actually the for P wave it's a longitudinal wave. So the particle moves in the direction of wave propagation. It moves by the continuous compression and dilatation of the medium. And for S wave, the it moves by the shearing strain, and the particle motion is the perpendicular to the direction of propagation. This is all I know.
Okay. So, in the P wave, is there rotation of the medium or not?
Rotation of the medium.
Yes.
No, I don't think so.
Okay. Does it involve uh, the equivoluminal waves? Which are the equivoluminal waves?
I have not heard about it.
Okay. Okay. Thank you.
Thank you.
Okay. Okay. One last question, general questions. So, what is the suppose it was a thing asked in the yesterday session. Suppose you are selected, then how will you contribute to the GSI?
Okay. Uh, I have not really thought about it. I'll have to think. Thank you for sharing the question.
Okay, thank you, Agya.
Thank you.
Okay, so for the feedback, you can give one by one. Uh, Pavan, you start.
Yeah. Arge, your confidence level also good, communication also good, and way of presentation for answering is also good. And tell me, Arge, you from geophysics background or physics backgrounds?
Physics.
Okay.
Any question that I missed, Pavan?
No, no, no.
Apita,
Again, your answer, way of presentation was also good. Communication was also good. And you answered my own correct questions correctly.
Thank you.
okay, Gauri,
Okay, your presentation was good. Yeah, overall, it was nice.
Sanu,
And one question I asked about the precautions to be taken for earthquake damage.
Yes, yes, yes. Please
Uh,
tell that.
I just meant uh, to avoid constructions if it is not a civilized area, or to obey the building codes, all those,
Okay.
or to educate people and give awareness.
Okay. Yeah. Thank you.
Sanu,
Okay, your knowledge and your confidence level is good, so I think keep it up. And so that's I from so all answers are good. Whatever I ask, all are good. All are corrected. Okay.
Thank you.
Amrit,
Okay, Orgo. Everything was superb, as everybody mentioned, and you know how to restrict yourself from elaborating a particular question. That is also good because that was not needed there. I asked you about a local magnitude scale, why Richter is called.
Yeah.
So, up to a certain distance, I don't know correctly the figure. It can be measured, the Richter magnitude scale. So it is better if we go through that. I will not give the wrong information. It can't measure distant earthquakes, and up to a certain limit it can measure the value. So it is called local magnitude scale.
Okay, yeah.
And uh, and you have answered all those questions quite well. That's it
I
from my side.
I missed one more. I think I forgot from yours.
Okay, I asked about fault.
Yeah, yeah. What is
What
fault?
is
What is
fault?
the definition?
Actually, this is a fracture within the rock
Acha,
layer,
Acha rock.
or
Okay.
it may not be at the earth surface. It is actually generating within the subsurface.
Yeah,
So
yeah.
it is better not to mention the location.
Okay.
Okay,
Thank you.
welcome.
Okay, Agya, there is nothing left for me to tell about your performance, your
You asked
communications,
about something. Yeah, yeah.
your communication way of presentations are good. Your knowledge is also good, and that the question you don't know, it's you skip. It's also good.
Thank
Okay,
you.
the questions I have asked about the train chart. So train chart it is using in the practice actually. Okay,
Yeah,
so it is the this chart is the concentric circles around the stations. So हम क्या करते हैं कि जो topography है, we will assume that topography as a cylindrical in shape, and then we divide sector by sector. So suppose I have chosen one sector, then uh, then I have to decide whether I will add it or not. Then the difference between for a particular sector, the topographic difference should be greater than the 5% distance of that sector from the station. So अगर वो जो हमारी हाइट का डिफरेंस है उस टोपोग्राफी में, और वो 5% के जो उसकी डिस्टेंस है स्टेशन से उस सेक्टर की, उसके 5% से ज्यादा है हाइट का, तो हम उसे कंसिडर करेंगे, वरना नहीं करेंगे. इट इज मेंशन इन द लॉरी बुक. एंड द अदर क्वेश्चन, कुछ और भी था शायद.
equivoluminal something.
हाँ हाँ हाँ, ओके. सो देखो, इन द एस वेव, इन द ओके, पहले तो मैं बता दूंगा बॉडी वेव्स एंड सरफेस वेव्स का. सो बॉडी वेव्स का जो वेव फ्रंट होता है, इट इज द स्फेरिकल वेव फ्रंट, और सरफेस वेव में सिलेंड्रिकल होता है. देन अगर एनर्जी प्रोपगेशन की बात करेंगे हम, डेफिनेटली इट इज 1/r उसका इन द स्फेरिकल वेव्स, बट सिलेंड्रिकल में 1/r होती है. सो एम्पलीट्यूड अगर हम देखेंगे तो 1/r आ जाएगा, उसमें 1/r आ जाएगा. देन फॉर स्मॉल डिस्टेंस वो एम्पलीट्यूड किस केस में ज्यादा डिक्रीज होगा, डेफिनेटली वो किस में डिक्रीज होगा, सरफेस फेस में, तो वो पहले पहुंच जाएंगे. इस वजह से हमारा ये होता है इसमें. और comes to the okay, so in the primary p waves there is the compression and the rarefaction of the medium, but there is no rotation, so
Yeah,
material do not rotate. Okay, but in the s wave there is a rotation because shearing is involved. Shearing is related to
yeah.
the rotation. Okay,
Right,
is
right.
but there is no change in the volume. So that's why in the formula we only have uh, the shear modulus in the s wave formula, the mu by rho. Okay, we don't have the bulk modulus. So from
Yeah,
these two formula देखो, p wave का जो है वो होता है k plus 4/3 mu upon rho, और वो होता है mu by rho. So जो bulk modulus है, it is the force per unit area required to compress the change the volume of the material. But जो shear modulus है, it is the force required per unit area to needed to change the shape of the material. एक में हम वॉल्यूम कर रहे हैं, एक में हम इसकी शेप चेंज कर रहे हैं, एंड शेप कैन बी चेंज ओनली बाय द रोटेशन. ओके,
yeah.
तो उसका ये आंसर है. एंड अदर बाकी, ओके, इट इज ऑन योर पर्सनल choice ki how will you contribute. So everyone will have to think about these questions because it depends upon your resume. Okay, your
Yeah,
point of view for the department. Thank you.
yeah.
Ashudip, you asked one question about the terrain correction. Why is it always included or avoided?
यस
Please
हाँ.
answer that.
हाँ, मैंने वो अवार्ड मैंने कहा कि ये प्रैक्टिस में यूज होता है बट इसकी जो लिमिटेशन है एज आई हैव ऑलरेडी टोल्ड कि जो हमारी टोपोग्राफी है, फॉर एग्जांपल हमारा स्टेशन है और स्टेशन के पास में एक हिल है, उसका हाइट का, अब उस हिल को हम एक, हमारे स्टेशन से उस हिल की कितनी डिस्टेंस है, फर्स्ट वो देखेंगे. हम क्या करेंगे, हिल को सेक्टर बाय सेक्टर डिवाइड कर देंगे, चाहिए सेक्टर एक की दो तीन चार इस तरीके से उस पर्टिकुलर डायरेक्शन के लिए. सो हम उसकी डिस्टेंस देखेंगे, अगर वो डिस्टेंस का 5% वैल्यू निकाल लेंगे, अगर अब उस पर्टिकुलर हिल की जो सेक्टर हमने लिया है अगर उसकी हाइट जो है उस 5% से ग्रेटर देन है तब हम उसे ऐड करेंगे वरना नहीं करेंगे. अब ये मैथमेटिकली कॉम्प्लेक्स चीज है तो बस कंडीशन दे में आस्क, दैट्स व्हाई आई हैव आस्क्ड दिस क्वेश्चन. सो should we continue or hello?
और कितने जन मतलब बाकी है?
Actually me and Gauri I think, huh?
Myself also. 3 people were left.
Okay, okay. So should we
We
continue?
can do it tomorrow. It's better, no? It
Yes,
will
yes.
be late.
हाँ हाँ हाँ. So tomorrow or day after tomorrow?
No, tomorrow is better because we have to.
Yeah. Why
Okay.
we
Oh,
need to extend over.
okay, okay, okay.